Imagine looking up at the night sky and knowing that something enormous, far larger than any comet or asteroid we've ever tracked, is hurtling toward our solar system right now. Not drifting, not passing by casually, but heading inward with a speed and precision that defy every prediction astronomers had. This is not a sensational headline or science fiction premise. It's the story of a newly detected interstellar visitor so mysterious that even the most conservative scientists admit they have no idea what it truly is. The first detection came quietly, almost accidentally, from a series of deep infrared scans mapping the faint edges of the heliopause. A tiny deviation, a faint flicker, a cold object reflecting just a thread of sunlight. When researchers isolated the signal, the numbers didn't make sense. The object was massive, far beyond typical comet scales, somewhere between 120 and 250 kilometers across, depending on albedo. But size wasn't the shocking part, its course was. This thing wasn't looping by, it was cutting directly toward the inner solar system on a high-speed path projected to take it closer to the Sun than any interstellar object on record. Within hours of confirmation, the astronomy community erupted. Observatories across the world turned their instruments toward the strange dark mass. They expected a frozen chunk of rock, inert and irregular, tumbling unpredictably. Instead, the object displayed a rotation so stable it felt engineered, turning with an almost mechanical consistency, one full spin every 11 hours. And even more unsettling were the reflective zones detected across its surface. Under intense sunlight, they flashed like metallic panels, arranged in lines and angles too sharp to be natural. At first, these anomalies were dismissed as data corruption, but the same results appeared from telescopes on 3 continents. Then came the acceleration. Over a span of just a few weeks, the object increased its velocity by a measurable amount, too subtle for the general public to notice, but far too precise for planetary scientists to ignore. No gravitational slingshot could explain it, no outgassing jets were detected, and yet something was pushing it forward, faster, deeper into our system. At that moment, astronomers realized the truth. They were watching an object that was not simply entering the solar system, it was aiming for it.
As more data arrived, one thing became clear. Whatever this thing was, it was not behaving like a natural interstellar body. When the James Webb Space Telescope finally captured high-resolution infrared data, scientists expected a familiar signature, a cold, dormant structure with weak thermal output. Instead, Webb detected pulsing heat, steady, rhythmic, and unlike any known natural pattern. These pulses weren't random. They followed a repeatable cycle, almost like a heartbeat, rising and falling every 19 minutes. Even stranger, the pulses intensified slightly each week, as if something inside the object were warming up. Models attempted to explain the phenomenon as crystallized volatiles releasing trapped energy, but the uniformity of the pulses shattered that theory almost immediately. Volatile pockets don't fire in perfect cycles. They certainly don't intensify on a clean curve. And they definitely don't cause smooth acceleration over millions of kilometers. The more astronomers watched, the more questions emerged. Why was the object rotating with such precision? Why did its trajectory shift to align closer with the ecliptic plane where our planets orbit? Why did its thermal emissions appear to radiate from beneath the surface rather than from sunlight alone? These mysteries sparked a flood of speculation. Ancient probe, derelict megastructure, fragment of a Dyson-like construct, or perhaps a completely unknown category of interstellar debris. But as always, official sources urged caution. NASA released conservative statements about unusual reflectivity patterns. ESA described unexpected but not unprecedented thermal behavior. But behind the scenes, urgency was rising. Data from the Deep Space Network revealed that the object's path wasn't just altering, it was stabilizing, settling into a trajectory intersecting the inner system. That's when mission planners realized something extraordinary. If projections held, the object would pass between Mars and Earth within 2 decades. Not close enough to threaten collision, but close enough to direct imaging, and close enough to reveal details we've never been able to observe about any interstellar visitor. What troubled researchers most was simple. The object was too stable, too orderly, too symmetrical, and it was becoming more active as it approached the Sun. Something inside it was changing, or waking up. And if that wasn't enough, new data from solar probes detected a never-before-seen interaction between the object and the solar wind, patterns so geometric they resembled engineered deflection.
As the object neared the heliosphere, we entered a completely new phase of discovery. For the first time, solar radiation reached it strongly enough to illuminate its full profile. What we saw left even hardened scientists shaken. The surface, once thought to be chaotic and cratered, revealed long, sharp ridges running in near straight lines. Some extended over 30 kilometers, with angles so precise they could have been drawn with a ruler. These were not the kinds of geological features that form from random collisions over millions of years. These looked intentional. Yet no one dared to say the word artificial publicly. Not yet. Instead, space agencies shifted focus to understanding the object's composition. Spectral analysis showed traces of metals rarely found in natural interstellar objects, including unusually high concentrations of nickel and iridium, metals often associated with the cores of planets or the remains of industrial alloys. Even more bizarre was the object's interaction with solar particles. Instead of scattering randomly, solar wind deflected around specific regions, suggesting a structured outer shell or conductive plating. It almost looked like shielding. But shielding for what? And then came the most astonishing discovery. Deep radar scans indicated interior cavities, large, hollow chambers beneath the surface. At first, researchers assumed these were natural voids created by sublimation or internal collapse, but the cavities were too geometrically consistent, shaped almost like vast corridors or compartments. When sunlight struck the surface, faint electromagnetic resonance echoed inside these chambers, producing harmonic vibrations unlike anything naturally occurring in cometary nuclei. These vibrations became stronger as the object moved deeper into the solar system. It was reacting to sunlight, or responding to it. Meanwhile, on Earth, mission planners debated the impossible question: should humanity attempt to intercept it? The fastest probes we've ever built couldn't catch it in time, so the strategy shifted instead to observation. Solar Orbiter, Parker Solar Probe, lunar-based telescopes, the entire scientific infrastructure pivoted to a single target. Just when it seemed we had a handle on the mystery, the object's rotation changed, slightly but undeniably. Not from an impact, not from a torque event, but smoothly, deliberately, as if something inside had adjusted its orientation. For many astronomers, this was the moment everything changed. A natural object doesn't correct itself mid-flight.
So what awaits us in the decades ahead? If current models are accurate, the object will continue accelerating until it reaches its peak velocity, near its closest approach to the Sun. During that passage, sunlight will reveal every detail of its structure: the metallic seams, the angular ridges, the thermal vents, and perhaps even the mysterious cavities inside. For a brief window, humanity will have an unprecedented look at a visitor that may have traveled for millions of years across interstellar space. Theories continue to multiply. Some scientists argue it could be a fragment of a shattered alien megastructure, a piece of something far larger, broken long ago in a cosmic catastrophe. Others propose it might be a dormant probe, engineered to reactivate when bathed in a star's light. A few believe it might be a relic, drifting aimlessly after the civilization that created it vanished. And of course, skeptics insist it is simply a bizarre but natural body, its impossible features still waiting for a rational explanation. The truth is, none of these possibilities can be ruled out. What we do know is this: the object is not behaving like a dead rock. It is warming. It is rotating with precision. It is adjusting its path. And it appears to be preparing, intentionally or not, for a very close passage through the inner solar system. When it does, every telescope humanity possesses will be trained on it. We will study its composition, its structure, its behavior, and perhaps even detect signals or emissions we cannot yet predict. This encounter will redefine what we believe about interstellar travel and the possibilities of civilizations beyond our own. For the first time in human history, we may witness an object older than our solar system passing close enough to touch with our instruments, maybe even close enough to raise new questions about our place in the cosmos. One thing is certain: the massive object heading straight toward the solar system is unlike anything we have ever observed. And as it approaches, the universe is giving us a rare opportunity to learn, to question, and to prepare for discoveries that could change everything we think we know about the stars, the void, and the distant worlds from which such an object may have come. The countdown has already begun. The object is coming, and whatever it truly is, it will not pass unnoticed.